Ancient architects mastered the cosmos with nothing but stone and sunlight. Long before telescopes or written language, they built observatories that could predict solstices, equinoxes, and even eclipses with stunning accuracy. By the end of this journey, you will understand the lost science that let them read the sky like a map. We will uncover how a single stone could mark the longest day of the year, and why certain tombs were designed to capture a single beam of light once every 12 months. What does it truly mean to build a doorway to the heavens? One summer solstice in the late 1800s, an antiquarian named William Flinders Petrie stood amidst the stones of Stonehenge and witnessed something that would change history. As the sun crested the horizon, its light shot perfectly through a specific archway of towering stones, striking a single, central slab known today as the altar stone. This was not a random act of nature. Petrie realized he was seeing the ghost of an intention, a deliberate act of engineering by people who had lived thousands of years prior. His observation sparked the birth of a new field of study, one we now call archaeoastronomy. This is not merely the astronomy of the ancients. It is the profound intersection of sky and culture, a discipline that asks how people long ago comprehended the celestial dance, how they wove that understanding into their architecture and their rituals, and what role the heavens played in shaping their very worldviews. It sits at the crossroads of anthropology and architecture, of myth and mathematics. At its heart, archaeoastronomy reveals a fundamental human drive, our relentless pursuit of order in the vast, often chaotic cosmos. By reading the alignments these builders left behind, we can begin to appreciate the intellectual triumphs of societies without written records. They could not write down their formulas or chart their discoveries on parchment, so they built their knowledge into the landscape itself, creating a permanent record in stone and shadow. This sophisticated understanding of cyclical time and celestial mechanics existed millennia before the invention of the telescope. It proves that keen observation and brilliant deduction are timeless human traits. This foundational science sets the stage for our journey into the methods of these ancient master builders. To truly grasp their genius, we must first look at the very stuff they worked with. Their primary materials were deceptively simple, yet they held the key to unlocking the secrets of the sky. That lone standing stone is a perfect example of the first principle, a silent signal in stone and shadow. It all begins with solar alignment, the deliberate orientation of structures to mark the sun's position at its most extreme points. Think of it as building a giant, permanent calendar on the landscape. The architects needed to solve a complex puzzle. They first had to identify a distant foresight, a fixed point on the horizon like a distinct mountain notch or a faraway peak. Then they established a backsight, the precise spot where an observer would stand, often marked by a stone circle or a single towering monolith. The goal was to make these 2 points frame the sun at a very specific moment, such as the summer solstice sunrise. At Stonehenge, the sun rising directly over the heel stone as seen from the center of the circle is the textbook example of this principle in action. It was not a one-time observation. Experts like Clive Ruggles stress that achieving this accuracy required generations of patient watching and recording. This was a science built over centuries, a legacy of knowledge passed down and refined. So the next time you watch a sunrise, ask yourself, could that sliver of light on the horizon have been a calendar marker for an entire civilization? This mastery of the sun's path was just the beginning, setting the stage for their work with the more subtle and mysterious light of the moon. The sun was a reliable partner, but the moon was a far more elusive and complex character in the celestial drama. Its path across the sky is a slow 18.6-year dance, a cycle where its rising and setting points slide north and south along the horizon. Every 18.6 years, this dance reaches its climax in events known as the major and minor lunar standstills. During a major standstill, the moon rises and sets at its farthest possible points, positions it will not reach again for another generation. Tracking this required a level of patience and precision that is almost unimaginable to us today. It implies a tradition of observation spanning multiple human lifetimes, a sacred duty passed from one knowledge keeper to the next. At the stone rings of Callanish in Scotland, the silent, lichen-covered monoliths appear to frame the moon at these extreme southern settings. Scholar Alexander Thom dedicated his life to mapping these alignments, arguing that the ancient builders possessed a sophisticated, almost mathematical understanding of this slow-moving clockwork. But why would they go to such extraordinary lengths? The answer may lie in the profound cultural significance of these events. A society that invests centuries in observing this celestial dance is one that sees its own rhythm reflected in the cosmos. The slow return of the standstill moon might have marked eras of renewal, of great ceremonial importance, or of re-establishing a covenant with the gods. This deep, generational investment in lunar knowledge reveals a mindset where time itself was cyclical and sacred, not a straight line to be rushed along. The moon's complex patterns were just a prelude, however, to the ultimate celestial spectacle, one that required them to synchronize the paths of both the sun and the moon in a single, breathtaking prediction. The sun and moon held their secrets, but the equinox presented a different kind of magic, a moment of perfect celestial balance. Deep within the pyramid of Kukulkan at Chichen Itza, a straight corridor waits in darkness for most of the year. Only on two specific days, the spring and autumn equinoxes, does a beam of sunlight pierce that inner chamber. This was not a random occurrence. It was a meticulously engineered event marking the 2 days each year when day and night are of equal length. For cultures that revered balance and harmony, this was a profoundly powerful symbol. The most breathtaking display of this principle happens not inside the pyramid, but on its grand staircase. As the sun sets on an equinox, the step terraces cast a series of triangular shadows along the balustrade. These interlocking shapes of light and dark create the undulating body of a serpent, appearing to slither down from the temple at the summit to meet its stone head at the base. This was the feathered serpent god Kukulkan descending to earth in a spectacle of light. Achieving this required more than just marking a sunrise. The builders needed an intimate, year-round understanding of the sun's shifting path and the masterful architectural skill to translate that knowledge into precise angles and dimensions. The pyramid itself became a colossal solar calendar and a theater for divine interaction. Could such a phenomenon have served a dual purpose, as both a public marker of time for farmers and a powerful, undeniable symbol of the ruler's connection to the gods? This architectural genius demonstrates a geometric understanding so advanced, it allowed them to capture a fleeting moment of cosmic balance and make it a permanent, repeatable feature of their world. This mastery of angles and alignment with the moving sun would soon be carved into the very bedrock of another continent, in structures designed to last for millennia. The descent of the serpent at Chichen Itza reveals a mind that thought in angles and proportions, a master geometer working on a colossal scale. But this geometric genius was not confined to the sun-drenched pyramids of the Maya. Far to the north, across the ocean, another culture was solving similar problems with ropes, stakes, and shadows. To understand their work is to step into the mind of a Neolithic architect for whom the world was a vast geometric canvas. Their tools were simple, but their vision was profound. They understood the properties of circles and right-angled triangles, principles we now call the Pythagorean theorem, long before the Greeks gave them a formal name. They used these concepts not as abstract mathematics, but as practical engineering, a way to impose cosmic order onto the chaotic landscape. The researcher Alexander Thom dedicated decades to surveying hundreds of stone circles across Britain. His meticulous work revealed something astonishing. These sites were not haphazard collections of boulders. They were precision instruments, built using a standardized unit of measurement he termed the megalithic yard, a length of roughly 2.72 feet that appears again and again from one site to the next. This was not a coincidence. It was evidence of a shared, sophisticated knowledge system, a building code for the heavens. At Stonehenge, this geometric rigor is breathtakingly clear. The four station stones form a perfect rectangle at the heart of the complex. The sides and diagonals of this rectangle do not just create a pleasing shape. They are precisely aligned to the most extreme rising and setting points of both the sun and the moon. This single geometric figure acts as a crystallized map of the sky's most important events. A builder with a rope and a few stakes could use this rectangle as a master template, scaling it up or down to create new observatories that captured the same celestial moments. This changes everything we thought we knew about these so-called primitive societies. They were not simply marking the sun with a single stone. They were encoding the entire celestial machinery into elegant, reproducible geometric forms. Their monuments were not just places of ritual. They were the Stone Age equivalent of an astronomer's mathematical model, a permanent computer built from earth and stone. The final sarsen stone locks into position on Salisbury Plain, and with it, a celestial blueprint becomes permanent. Stonehenge was far more than a circle of rocks. It was a Neolithic computer, its very architecture encoding the complex movements of the sun and moon across generations. Its construction was not a single event but a series of evolving phases, each reflecting a deeper understanding of the cosmos. The long processional avenue leading to the circle points directly to the horizon where the summer solstice sun first appears, a grand entrance for the year's most powerful light. But the true genius lies in the details. The ring of 56 pits known as the Aubrey holes may have been the key to predicting one of nature's most dramatic events, the eclipse. By moving markers around this circle, one pit per year, ancient astronomers could track the moon's subtle 56-year cycle, anticipating the moments when the sun and moon would align to create darkness at midday. Inside the main circle, the massive trilithon arches frame the winter solstice sunset, proving these builders were not just focused on the summer. They were mapping the sun's entire journey from its peak strength to its deepest retreat. And the story does not end there. Recent laser surveys have uncovered subtle carvings of axe heads and daggers on the stones, markings that some researchers believe could be a map of the constellations glittering above. Was Stonehenge a unified theory of the cosmos, a single structure designed to harmonize the cycles of the sun, moon, and stars in one grand stone symphony? This masterpiece of megalithic engineering challenges us to look beyond the famous circles and discover the subtle genius hidden in plain sight at other, quieter sites. Deep within the rolling green hills of Ireland, a great stone mound has guarded its secret for over 5,000 years. Newgrange is a passage tomb older than Stonehenge, older even than the Great Pyramids of Egypt. From the outside, it appears as a vast, grassy dome encircled by a wall of white quartz, a silent and ancient presence in the landscape. but its true purpose reveals itself for just a few precious minutes each year at the dawn of the winter solstice. The entrance is marked by a unique feature, a narrow slit carved perfectly above the doorway known as the roof box. For the rest of the year, the long 19-meter passage behind it remains in profound darkness, a corridor leading to a central chamber where the remains of the departed were laid to rest. This was far more than a tomb. It was a machine built for a single, breathtaking moment of celestial alignment. As the sun crests the horizon on the shortest day of the year, a brilliant, narrow beam of light pierces through the roof box. This sliver of sunlight does not simply flood the chamber. It travels slowly, deliberately, down the stone passageway, pushing back the darkness until it illuminates the intricate spiral carvings deep within the central room. This event lasts for approximately 17 minutes, a fleeting burst of light and warmth in the heart of the darkest season. The engineering required to achieve this was anything but simple. The builders had to calculate the precise angle for the roof box, ensuring it would capture the sun at its lowest, most southern point on the horizon. A miscalculation of even a single degree would mean the chamber would remain dark on that sacred day. This was a monument to precision, a testament to generations of sky watchers who understood the sun's slow journey with intimate clarity. What did this annual miracle mean to the people who gathered there? We can only imagine the powerful emotions it must have stirred. In the depth of winter, when the world seemed cold and lifeless, the sun would return as promised to reclaim the land. The light reaching into the chamber, a place of final rest, would have been a profound symbol of rebirth, a promise that life and warmth would always triumph over darkness and cold. It connected the cycle of human life directly to the cycle of the cosmos. This was a cosmological statement carved in stone, a declaration that the heavens were not distant and separate, but intimately woven into the fabric of life, death, and renewal. The silent, patient architecture of Newgrange proves that this deep connection between sunlight and spirituality was a powerful force across the ancient world, one that would find equally stunning expression far across the ocean. A hush falls over the crowd gathered at the base of El Castillo. The late afternoon sun on the spring equinox hangs low in the sky, and as it descends, something impossible begins to happen. The pyramid's northwest corner casts a series of 7 distinct, triangular shadows onto the balustrade of the main staircase. These interlocking shapes of light and dark connect, forming the undulating body of a massive serpent. For over 20 minutes, this creature of pure shadow appears to slither down from the temple summit, finally meeting the great stone serpent head carved at the base of the staircase. This is the descent of Kukulkan, the feathered serpent god, made manifest through a miracle of architectural precision. This was not magic, but a masterwork of public astronomy, a spectacle designed to be witnessed by the entire community. The pyramid itself is a complex calendar carved in stone. Its 4 sides, each with a staircase, total 365 steps, one for each day of the solar year. The 9 terraced levels are divided by the staircases, creating 18 distinct sections that mirror the 18 months of the Mayan Hob calendar. And on each face of the structure, you find 52 carved panels, representing the critical 52-year cycle when the solar and sacred calendars would realign, a moment of profound renewal for Mayan society. This convergence of mathematics, astronomy, and architecture served a powerful social purpose. The ruler, standing at the summit as the serpent descended, was visually transformed into the divine intermediary, the one who could command the very sun to perform for the people. It solidified a cosmic order in the minds of every witness. The experience here at Chichen, Itza, stands in stark contrast to the private, intimate light show at Newgrange. One was a grand public declaration of power, the other a deeply spiritual event witnessed by a select few in a sacred chamber. Both, however, shared the same profound understanding that human time and celestial time were one and the same. This mastery of cyclical time was not unique to the Maya. Further south, in the rugged highlands of the Andes, another civilization was engineering its own breathtaking dialogue with the cosmos, carving their astronomical knowledge directly into the living rock of the mountains. High on a stone altar in the Andean clouds, the Intihuatana stands as a perfect fusion of art and science. This hitching post of the sun is not a random sculpture, but a masterfully carved granite pillar, an astronomical instrument of stunning precision. The Inca stonemasons shaped its complex angles and planes with incredible skill, aligning it perfectly with the four cardinal directions and the sun's annual journey. This allowed the pillar to function as a sophisticated solar clock. Throughout the year, the shadow cast by the central pillar falls across its carved base in a predictable, changing path. On the equinoxes, the shadow would be at its most balanced, while on the solstices, it would reach its shortest or longest extreme, marking the sun's turning points with unerring accuracy. This was not abstract observation, it was the very heartbeat of an empire. Priests could read these shadows like a calendar, determining the exact, most auspicious days to plant and to harvest, anchoring the entire agricultural cycle to the stone. This deep reliance on the sun reveals a society whose survival was woven directly into the fabric of the cosmos. The Intihuatana was the central gear in a much larger celestial machine. Just below it, the semicircular temple of the sun features a window perfectly oriented to capture the first rays of the June solstice sunrise, illuminating a ceremonial stone within. The site's very placement was a cosmological statement, nestled between sacred mountain peaks that were themselves considered divine beings. In this world, there was no separation between the earthly and the heavenly. The mountains were the pillars of the sky, and the observatories built upon them were points of direct communication. The preservation of such a precise instrument, even after centuries, speaks to the enduring power of this worldview. It underscores a society that saw its prosperity, its rituals, and its very identity as a reflection of the orderly motions above. This high-altitude astronomy, conducted amidst thin air and towering peaks, presents a stark contrast to the desert observatories being built at the very same time far to the north. Far from the Andean peaks, in the dry, high desert of New Mexico, the ancestral Pueblones orchestrated their own celestial symphony in stone. Chaco Canyon stands as a testament to a society that organized its entire world around the sky. The scale of their ambition is staggering, a sprawling complex of great houses, ceremonial kivas, and precisely engineered roads that stretch across the harsh landscape. At the heart of this system lies the Great Kiva of Cosa Rinconada, a massive, circular underground chamber. Its architecture is a marvel of alignment, oriented perfectly on a north-south axis with a series of niches and windows positioned to capture the solstice sunrises. This was not merely a building, it was a calibrated instrument designed to frame the most important moments of the solar year, transforming the movement of the sun into a sacred event witnessed by the entire community. But the true signature of Chacoan genius is found high above the canyon floor, on a remote sandstone ledge of Fajada Butte. Here, three massive, carefully positioned stone slabs stand guard over a spiral petroglyph carved into the rock face. For most of the year, these slabs cast unremarkable shadows, yet on the day of the summer solstice, a sliver of sunlight pierces through the narrow gaps between the stones, forming a sharp, dagger-like beam of light that perfectly transects the center of the spiral. At the winter solstice, two distinct daggers of light appear, framing the spiral on either side. This sun dagger was a stunningly precise solar calendar, a public declaration of cosmic order etched into the very cliffside. This obsession with celestial alignment permeated the entire canyon. The immense building of Pueblo Bonito, with its sweeping crescent shape, is aligned along a perfect east-west cardinal line. Some researchers suggest that its walls and openings were designed to mark the much slower, more complex cycles of the moon, including its major and minor standstills. This implies a tradition of observation spanning generations, a patient accumulation of knowledge about the moon's 18.6-year dance. Why would a society pour such immense resources into this remote, ceremonial center? The answer may lie in the vast network of straight roads that radiate out from Chaco, connecting it to outlying communities hundreds of miles away. These were not simple trade routes. They were likely ceremonial pathways, physical lines of connection that tied a widespread culture to this spiritual and astronomical hub. Chaco Canyon was the beating heart of a cosmology, a place where the rhythm of the heavens dictated the rhythm of life, from agriculture to ceremony. To build such a precise and enduring observatory required more than just grand vision. It demanded a suite of simple yet brilliant tools for daily observation. A simple stick planted firmly in the earth could become a powerful cosmic instrument. This was the gnomon, the most fundamental tool in the ancient astronomer's kit. By carefully observing the shadow it cast, a sky watcher could unlock a wealth of information. The direction of the shortest shadow at local noon pointed unequivocally to true north. The length of that shadow changed with the seasons, reaching its maximum at the winter solstice and its minimum at the summer solstice. With nothing more than a marked circle drawn around the base of the stick, they could even track the hours of the day. This elegant simplicity was the foundation upon which celestial knowledge was built. In ancient Egypt, this principle was refined into the merkit, a tool of breathtaking precision. It consisted of a horizontal bar with a slit in it, used like a sight, and a plumb line hanging from it to ensure a perfectly vertical reference. A priest astronomer would use a pair of these instruments, aligning their sights with specific stars as they crossed the meridian. This allowed them to determine true north with astonishing accuracy, an essential first step for aligning their massive pyramids and temples to the cardinal directions. Their entire architectural legacy, which has endured for millennia, began with this simple act of sighting a star. But how did they track the passage of time when the sun was gone? For nocturnal observations, they relied on the clepsydra, or water clock. This device measured time by the steady drip of water from one container into another, with marked levels inside indicating the hours. It was the steady heartbeat of the night, allowing them to log the precise moment a star rose or set, building the long-term data needed to understand celestial cycles. This patient, cumulative science, conducted with basic tools, eventually led to marvels of mechanical genius. The Antikythera mechanism, recovered from a Greek shipwreck, stands as a stunning example. This intricate bronze device, with its complex gearing, could predict planetary positions, lunar phases, and even eclipses. It was an analog computer of staggering complexity, proving that the conceptual leap from a shadow stick to a mechanical predictor was entirely possible within the ancient world. Yet the roots of this astronomical tradition reach back even further, into the very dawn of human cognition. A small, curved bone from over 20,000 years ago, known as the Blanchard bone, is etched with a series of notches. Analysis suggests these marks are a tally of the moon's phases, a painstaking record of its waxing and waning. This artifact hints at a profound realization, one of humanity's first great intellectual leaps, that the seemingly chaotic night sky held a deep, predictable order. So, does our reliance on silicon and satellites blind us to the sheer power of simple observation? These ancient tools were not primitive. They were perfectly adapted to their purpose, requiring no power source other than human curiosity and yielding results that shaped civilizations. The grand monuments we marvel at today, from the Great Pyramid to Stonehenge, were not spontaneous creations. They were the ultimate expression of knowledge first gathered one shadow, one star transit, one water drop at a time. That single beam of sunlight piercing a dark temple was far more than a celestial event. It was a political statement carved in light. When a ruler stood bathed in solstice illumination, they were not just a person, they became a divine intermediary, their authority endorsed by the cosmos itself. This controlled manipulation of light within sacred architecture was one of the most powerful tools for social control ever devised. By claiming ownership of the calendar and the ability to predict the heavens, the ruling elite held the keys to society's most vital rhythms. They could declare the optimal time to plant and to harvest, to begin a war or to hold a festival. This was not just knowledge, it was power, legitimized by a direct and visible link to the gods. The phenomenon at the great temple of Abu Simbel in Egypt offers a breathtaking example. There, on 2 specific days of the year, the rising sun would reach deep into the mountain, its rays illuminating the statues of 3 gods seated in the inner sanctuary. The 4th statue of the god of the underworld remained forever in shadow, a detail of profound theological significance. This annual event, though the temple was meticulously relocated in the 1960s, perfectly reflects the ancient intent, a dramatic public spectacle engineered to inspire awe and reinforce a cosmic order that mirrored the social hierarchy. So were these structures astronomical observatories, houses of worship, or instruments of power. The truth is, they were all 3 seamlessly intertwined. The stone was the science, the light was the scripture, and the effect was absolute social cohesion. This carefully cultivated awe reached its zenith when the elites could predict not just the regular cycles, but the most terrifying and unpredictable celestial events of all. The ultimate test of this celestial knowledge was predicting the terrifying moment when the sun itself would vanish. For an ancient society, a solar eclipse was not a scientific curiosity. It was a cosmic crisis, a sign of divine displeasure or a struggle between celestial powers. The ability to foresee such an event was the pinnacle of astronomical power, transforming chaos into order and fear into awe. This incredible feat was often achieved by tracking a long, slow rhythm known as the Saros cycle. This is a period of approximately 18 years and 11 days after which the sun, the moon, and the earth return to almost the exact same alignment, causing a similar eclipse to occur. But how do you track a cycle that spans generations? The answer may lie in the quiet, circular arrangement of the 56 Aubrey holes at Stonehenge. Researchers propose that these pits functioned as a massive Stone Age counting device. By moving a marker from one hole to the next each year, priest astronomers could track the passing of 3 Saros cycles, which neatly equals 56 years. This simple yet brilliant system would have allowed them to anticipate the dangerous window when an eclipse was possible, giving them the power to prepare their people, perform the necessary rituals, and demonstrate their unquestioned connection to the gods. Far across the Atlantic, the Maya developed an even more precise system, recording their intricate knowledge in the Dresden Codex. Their eclipse tables reveal a profound understanding of the moon cycles, allowing them to predict not just the possibility, but the timing and type of eclipse with remarkable accuracy. So what did it truly mean for a civilization to hold this knowledge? It meant that the most fearsome celestial omen could be tamed. The ruling class did not just predict an eclipse, they scheduled it, framing it not as a disaster, but as a reaffirmation of their sacred duty to maintain the cosmic balance. This ability represents the magnificent culmination of all the techniques we have explored, from the simple gnomon to the grandest pyramid. It was the moment when observation became prophecy, and architecture became a key to unlocking the future itself. The stones themselves were never just stone. They were the anchors of an entire cosmic order, a world view where the sky was a living, sacred text read daily by priests and farmers alike. This cultural cosmology saw no separation between the heavens and the earth. The sun was a deity on a daily journey, the moon a powerful cyclical force, and the stars were the eternal, watchful ancestors. Human fate was woven directly into this celestial tapestry. This profound connection meant that the layout of a city, a temple, or a tomb was never arbitrary. It was a deliberate act of creating a microcosm, a small-scale model of the universe built to harmonize human life with the divine rhythm above. In ancient Egypt, life itself depended on the Nile's annual flood. The river's life-giving rise was not a random event. It was heralded by the heliacal rising of the star Sirius, when it first became visible just before dawn after a long absence. This celestial signal meant the flood was coming, and with it the renewal of the land. The Egyptians built their entire calendar around this star, this single point of light in the vast darkness that dictated their survival. Their architecture echoed this cosmic mirroring. The narrow shafts within the Great Pyramid were not simply air vents. They were precise sightlines pointing directly to the circumpolar stars, the so-called indestructibles that never set. These stars were linked to the soul of the pharaoh and his eternal journey in the afterlife. The pyramid was not just a tomb, it was a launch pad to the heavens, a machine designed to connect the ruler's spirit with the timeless, unchanging stars. Far across the world in Mesoamerica, this cosmic drama was played out on the ballgame court. The court itself was a representation of the universe, and the game was far more than sport. It was a reenactment of the celestial battle between the forces of light and darkness, often symbolized by the sun and the moon or the hero twins of their mythology. The outcome of the game held profound ritual significance, sometimes even tied to matters of life and the community's well-being. So how did this deep, pervasive connection shape the average person's life? It provided a framework for existence. The calendar dictated by the sky told you when to plant, when to harvest, when to marry, and when to honor the gods. It created a social structure where the ruling class, who held this celestial knowledge, were the essential intermediaries between the people and the powers that controlled their fate. This holistic view made the immense effort of building a Stonehenge or a pyramid of the sun not a burden, but a sacred duty. It was the ultimate expression of a society's desire to live in harmony with a universe they saw as alive, intelligent, and intimately connected to their own. This silent, generational conversation was held not in ink, but in story and stone. Think of the monumental task these ancient astronomers faced, preserving intricate celestial data for centuries without a single written manual. Their solution was a living library, a sophisticated system of knowledge transmission that wove science into the very fabric of culture. A master sky watcher would have spent decades training a chosen apprentice, not in a classroom but under the open sky. They memorized the subtle shifts in a star's position, the changing length of a noonday shadow, and the slow 18-year dance of the moon. This was not rote learning. It was the slow, deep absorption of a cosmic rhythm. The knowledge was encoded for easy recall in epic poems, in creation myths where heroes became constellations, and in ceremonial songs whose verses counted the days between solstices. The structures they built were the ultimate mnemonic devices. An initiate could stand in the center of a stone circle, and by reciting a specific chant that named each stone, remember the exact alignment for the winter solstice sunset. The architecture itself was the permanent, unchangeable text, a backup copy carved into the earth that could always be referenced if the oral tradition ever faltered. Seasonal ceremonies were the final, crucial step in this process. When the entire community gathered at a site like Newgrange to witness the solstice sunrise illuminate the inner chamber, they were not just spectators. They were participants in a powerful, experiential lesson that reinforced the celestial order for everyone, from the eldest elder to the youngest child. This collective memory, reinforced by ritual and anchored by immutable stone, ensured the knowledge survived through countless generations. So was a site like Stonehenge a library. In the most profound sense, yes. Its stones were the shelves, the alignments were the books, and the trained keepers of the tradition were the librarians. This system's success forces us to reconsider what we mean by education, proving that some of humanity's most complex science was once held securely in memory, melody, and the meticulous placement of a single rock. Some stones hold more than just the memory of sunlight. Deep within the hypogeum of Hal Saflieni, a labyrinth carved entirely underground in Malta, a single word spoken in one of its oval chambers can be heard with perfect clarity in another room far across the complex. This is not a coincidence of construction. It is the mark of a forgotten science, a field we now call archaeoacoustics, which studies the intentional sound properties of ancient spaces. These builders were not just masters of light, they were engineers of vibration and resonance. They understood that a sacred experience was not solely visual. By designing chambers that could amplify a chant or transform a drumbeat into an overwhelming, all-encompassing resonance, they could alter human perception itself. Imagine the profound impact of a ritual held at dawn on a solstice. As a sliver of sunlight pierced the inner sanctum, the air would also be thick with rhythmic sound, a physical vibration that could induce trance-like states. The visual spectacle of the celestial event was now paired with a sonic immersion, creating a multi-sensory gateway to the divine. This combination was likely a deliberate tool, a way to dissolve the boundary between the individual and the cosmos, making the celestial harmony not just something to be observed, but something to be physically felt and heard. Were these sites designed as resonance chambers to help participants literally vibrate in sync with the universe? This sonic layer adds a profound dimension to sites like Mayan temples, where the clap of hands on a pyramid steps echoes back as the chirp of the sacred Quetzal bird. The architecture itself was singing, and its song was part of the celestial ceremony. This intricate blending of sensory experiences points to a mind that saw the cosmos as an interconnected whole, a philosophy that would soon face its greatest challenge from a new way of thinking. The ambition of these architects extended far beyond single structures, spilling out to reshape the very horizon itself. They began to think on a colossal scale, treating entire valleys and plains as their canvas for cosmic diagrams. This was sacred geography, the practice of weaving celestial patterns directly into the landscape, merging human ritual space with the natural and heavenly worlds. In the stark plains of Peru, the Nazca lines present one of history's most breathtaking examples. These vast geoglyphs etched into the desert floor are not merely images of animals and shapes. Many of the long, arrow-straight lines function as sightlines, pointing directly to the spots on the horizon where the sun and certain bright stars would rise or set on significant dates. The entire desert was transformed into a giant astronomical observatory, a calendar so immense it could only be fully appreciated from a perspective these creators likely never physically achieved. Across the globe in Cambodia, the vision was even more grand. The temple of Angkor Wat is precisely aligned so that on the spring equinox, the sun rises directly over its central tower. But the alignment does not stop at the temple walls. The main axis of the entire sprawling Inca complex, a city covering hundreds of square miles, was laid out to mirror the sinuous form of the constellation Draco in the northern sky. The Earth itself was made to reflect the dragon of the heavens. In England, the path to Glastonbury Tor, a natural hill with ancient terraces, may have been a processional way aligned with specific stellar risings, turning a pilgrimage into a walk through the stars. To inhabit such a landscape was to live inside a map of the cosmos. Every hill, every pathway, every temple was a constant reminder of a celestial order. This macro-scale planning represents the ultimate ambition of the ancient cosmologist, a desire to not just observe the heavens, but to build a world that was their perfect mirror. That same human drive to find order in the stars did not vanish with the last standing stone. It echoed through the ages, a quiet inheritance that would one day fuel the scientific revolution. The founders of modern astronomy, figures like Copernicus and Kepler, were engaged in the very same quest as the megalithic builders, just with different tools. They too were pattern seekers, staring into the night sky and trying to decipher its hidden logic. The crucial difference was that they stood on the shoulders of giants, benefiting from millennia of naked eye observation meticulously recorded by their ancient predecessors. This long-term data collection was the indispensable foundation. The Greek astronomer Meton, for instance, formalized a 19-year cycle that harmonizes the solar and lunar calendars, a concept we still use today to calculate the date of Easter. But this was not a purely Greek invention. The same 19-year pattern and the more complex 56-year cycle tracked at Stonehenge show that this sophisticated understanding of synchronizing the sun and moon was being worked out in stone thousands of years earlier. The legacy is not just in raw data, but in the very shape of abstract thought. The precise mathematical constants encoded in the Great Pyramid of Giza, where the ratio of its perimeter to its height equals 2 pi, or the perfect Pythagorean triangles found in the layout of Stonehenge, are not mere coincidences. They are evidence of a developing mind capable of grasping universal, abstract principles from the physical world. This ability to move from observation to mathematical law is the very engine of science. Perhaps the most profound gift from these ancient sky watchers was not a specific number or cycle, but a foundational belief, the concept of a cosmos governed by consistent, predictable laws. When a priest at Chaco Canyon could predict a solstice sunrise to the minute, or a Mayan astronomer could forewarn of an eclipse, they were demonstrating that the universe was not chaotic or capricious. It operated on a set of rules that could be understood through patient observation. This was the essential precursor to the work of Kepler, who spent his life searching for the mathematical harmonies he was certain governed planetary motion. He believed the universe was built on geometric perfection because generations of his intellectual ancestors had already proven that the sky was predictable. So how much do we truly owe to these first astronomers? The debt is immeasurable. They gave us the first calendar, the first maps of the stars, and the first inklings of mathematics. More importantly, they gave us the confidence to look up and believe we could understand what we saw. This long chain of knowledge, stretching from a bone tally marked under a Paleolithic moon to the space telescopes of today, is one of humanity's greatest collective achievements. Recognizing this shared legacy makes the preservation of their remaining works, from the Intihuatana to the Callanish stones, not just an archaeological concern, but a duty to our own intellectual heritage. But this grand narrative of cosmic architects is not without its critics. A deep and necessary debate simmers just beneath the surface of archaeoastronomy, a field often caught between the awe of discovery and the rigor of scientific skepticism. On one side are the alignment hunters, scholars who can sometimes see a precise observatory in every pile of old stones. Their enthusiasm is infectious, but it risks seeing patterns where none were intended, like finding pictures in the clouds. The pioneering work of Alexander Thom, for instance, which revealed the potential use of a standard megalithic yard, has been challenged by those who argue he may have been imposing a modern, mathematical mindset onto prehistoric builders who operated with different intentions. Was a circle of stones a sophisticated astronomical computer, or was it primarily a sacred gathering place that incidentally faced the rising sun? This is the central tension. Even celebrated sites are not immune to scrutiny. The stunning sun Dagger at Chaco Canyon, a symbol of ancestral Puebloan genius, presents a thorny problem. The three large stone slabs that create the light dagger are not fixed in concrete. They have likely shifted over the centuries, even if only slightly, due to natural settling and erosion. This means the perfect alignment we see today may not be exactly what the original builders designed. The dagger of light that so precisely bisects the spiral petroglyph at the solstice could be the result of a fortunate accident of time, a beautiful coincidence that was not part of the initial plan. So how do we sift the intentional from the incidental? The answer lies in a three-part test, a method that separates rigorous science from mere speculation. First, we must have strong archaeological evidence. Were there artifacts or remains found at the site that suggest it was used for sky watching? Second, we need cultural context, often drawn from ethnographic records of descendant peoples or from ancient myths and texts that explain the importance of certain celestial events. And third, we require statistical significance. If one window in a temple aligns with the sunset, that could be chance. But if multiple features within the same structure all point to key solar, lunar, and stellar events, the probability of that being random drops dramatically. This critical, questioning perspective is not meant to destroy the wonder. It is the very process that grants these ancient wonders their true credibility. By demanding more than just a compelling alignment, we move from telling a good story to uncovering a deeper, more authentic truth about how our ancestors saw their place in the universe. The slow wobble of Earth's axis is a clock that ticks once every 26,000 years. This grand cycle, called precession, means the entire celestial sphere is in constant, gradual motion. The stars we see as fixed are not, and the precise point of the solstice sunrise creeps almost imperceptibly along the horizon over the centuries. An alignment that was perfect for the builders of Stonehenge or Newgrange is now subtly out of sync, a ghost of its former precision. This is not a flaw in their work, but a profound key to unlocking it. To understand what they saw, we must rewind the sky. 5,000 years ago, when the Great Pyramid of Giza was new, the North Star was not Polaris. It was a star in the constellation of Draco named Thuban. The narrow, southern shafts within the pyramid, which today point to nothing of obvious significance, were once perfectly aligned with the passage of Thuban across the meridian. These shafts were not ventilation channels, they were sightlines to a celestial throne, a direct link for the pharaoh's spirit to the unchanging pivot of the sky, as it was known in his time. By calculating this precession backwards, researchers can perform a kind of celestial archaeology. They can determine the exact era when a temple's entrance framed a specific star, or when a solstice sunrise would have shone directly down a main avenue. This turns the slow drift of the cosmos into a powerful dating tool, a chronological verifier for claims about a structure's original purpose. If an alignment only makes perfect sense for the sky as it appeared in 2500 BC, then we have compelling evidence for its construction date. So the next time you look at the steady North Star, remember it is a temporary guide. in a few thousand years another star will take its place, just as it was for the Egyptians. This grand perspective challenges our sense of permanence. Does the slow dance of precession mean that these ancient sites are slowly losing their connection to the heavens they were built to honor? Or does it instead reveal the incredible foresight of their architects, who built for an age they knew would change? The stars have always been a shared inheritance, yet the hands that held this knowledge were far more diverse than our traditional histories suggest. Reimagining the past requires us to look beyond the solitary male figure gazing at the stars and consider the vital, often overlooked roles played by women. In many ancient societies, women served as priestesses, master weavers, and the dedicated keepers of calendrical knowledge. This connection was often woven into the very fabric of their cosmology. The moon, with its rhythmic 28-day cycle of waxing and waning, was frequently associated with female deities and the natural cycles of life. This profound symbolic link strongly suggests that women were among the primary observers and interpreters of the lunar phases, their lives intimately synchronized with its celestial rhythm. Consider the legacy of the Greek poet Sappho, whose verses lovingly describe the setting of the Pleiades star cluster, marking the time for harvest and the onset of winter. Or the Norse goddess Sif, whose legendary hair of gold was not merely a symbol of beauty, but a direct metaphor for ripe grain, linking her divine power to the solar cycles that governed the harvest. This was not mere mythology, it was a framework for living. In some Native American traditions, this knowledge was made manifest through craft. Women were often the ones who created and maintained intricate calendar sticks, notched to track the passing days and lunar months. The very patterns woven into their baskets and textiles could serve as mnemonic devices, encoding seasonal information and celestial events into art. Ethnographic studies of surviving traditional societies frequently reveal women playing central roles in astronomical observation for deeply practical purposes. They determined the optimal times for planting, for harvesting, and for ceremonial gatherings, their eyes trained on the horizon just as keenly as any hunters. How does incorporating this gendered perspective enrich our understanding of ancient sky watching? It transforms the narrative from a tale of lone geniuses to a story of an entire community's intelligence. It acknowledges that the grand monuments we study today were likely born from a collective effort, where the quiet, consistent observations of women provided the foundational data that shaped empires. This broader view does not diminish the achievements of the architects, but rather completes the picture, revealing a civilization where every member had a part to play in the great, ongoing dialogue with the cosmos. A stone that has stood for 5,000 years now faces threats its builders could never have conceived. The very air we breathe carries a new kind of danger, as industrial pollution turns rainwater acidic. This acid rain works silently, dissolving the surfaces of ancient monoliths, smoothing away the intricate carvings and subtle markings that may have been essential to their function as astronomical tools. The foundations of these precise structures are also at risk. Groundwater extraction for modern agriculture can destabilize the earth beneath them, while natural seismic activity can cause imperceptible shifts. A movement of just a few centimeters is enough to throw a perfect solstice alignment into permanent error, severing the monument's connection to the cosmos it was built to honor. Perhaps the most pervasive threat is the glow of our own progress. Light pollution from expanding cities bleaches the night sky, obscuring the faint stars and delicate lunar paths that these sites were designed to track. The ancient observatory becomes a silent instrument in a room with no windows, its purpose muted by a permanent, artificial dawn. International bodies like UNESCO lead a constant battle to protect these irreplaceable sites, implementing measures to manage the impact of millions of visitors whose footsteps compact the Earth and contribute to gradual erosion. But this is more than an archaeological concern. These places were humanity's first laboratories, the birthplaces of calibrated observation and predictable science. To lose them is to erase a fundamental chapter in our collective intellectual history. Their growing fragility forces a profound question upon us. What is our responsibility to the silent teachers of stone, and how do we ensure the celestial conversation they began does not end with our generation? A digital sky now hangs over these ancient stones, a virtual canvas where the past is reborn in light and code. With a few clicks, an archaeologist can peel back the centuries, rewinding the sky to the very moment a temple was consecrated. Software like Stellarium acts as a celestial time machine, calculating the slow precession of Earth's axis to show us the stars not as they are today, but as the builders of Stonehenge saw them. This is not just a simulation, it is a revelation. We can now stand in the exact center of a ruined circle and witness the winter solstice sun crest the horizon in its precise 5,000-year-old position, a view once reserved for a long-vanished priesthood. This digital toolkit extends to the very ground beneath our feet. Three-dimensional laser scanning, known as LiDAR, bathes a site in millions of invisible laser pulses, building a millimeter-perfect digital twin of every stone, every subtle contour of the land. Faint alignments and architectural details, worn away by time and invisible to the human eye, are suddenly revealed in stark clarity on a computer screen. How does this revolution change our understanding? It allows for a new kind of experimentation, one that protects the fragile originals. Researchers can test 100 different astronomical hypotheses in a virtual model without ever touching the sacred stones. They can simulate the path of a single beam of sunlight through a reconstructed temple on the spring equinox in 1500 BC, watching where it falls, what it illuminates. This non-invasive digital archaeology is confirming some of the most sophisticated claims about these ancient wonders, turning speculative theory into verifiable fact. It proves that the patterns we suspect were not accidents of construction, but the products of a deep and deliberate cosmic intelligence. From the windswept plains of Wyoming to the sun-baked islands of Malta, a silent conversation unfolds in stone. The Bighorn Medicine Wheel, a perfect ring of white stones laid out upon a high mountain plateau, frames the summer solstice sunrise and the rising of key stars like Aldebaran. On the other side of the world, the Mnajdra Temple complex, built from massive limestone blocks, features doorways and altars precisely aligned to catch the equinox sun. These cultures never met, they shared no technology, and yet they both invested immense effort to solve the same cosmic puzzle. This pattern repeats across the globe. In France, the thousands of standing stones at Karnak stretch for miles, their long rows potentially acting as sightlines for lunar standstills. In India, the ancient city of Ujjain was considered a prime meridian for Hindu astronomy, with observatories built to track the sun, moon, and planets with astonishing accuracy. The universal foundation for all of these endeavors was the solar cycle. The solstices and equinoxes were the most reliable, visible celestial milestones, the steady heartbeat of the year that every agricultural society needed to understand for its very survival. This was the common ground, the shared question posed to the heavens by humanity, but the specific answers they sought, the celestial bodies they chose to venerate, varied dramatically. In Western Europe, the focus remained largely on the grand, predictable duet of the sun and the moon. In Mesoamerica, however, the Maya possessed an obsession with Venus, meticulously charting its cycles as the morning and evening star and weaving its movements into their sacred calendars and the timing of royal events. Meanwhile, the Polynesian navigators who crossed the vast Pacific viewed the sky as a nautical chart. They built open-air temples called mari from coral and stone, not just for solstice markers, but as schools of celestial navigation, learning the star paths that would guide their voyaging canoes between invisible islands. This global perspective reveals a stunning diversity of materials and methods, each perfectly adapted to its environment. The builders of Stonehenge wrestled colossal sarsen stones across the landscape. The Inca stonemasons at Machu Picchu carved intricate bedrock and fitted granite blocks with impossible precision. The Polynesians used the materials at hand, stacking coral bricks to create their sacred spaces. So why does this same profound idea, this impulse to build a calendar in stone, appear again and again across isolated continents? It points to something fundamental in the human mind, a shared drive to find order in the cosmos, to mark our place in time, and to seek meaning in the relentless, beautiful cycles of the sky. We were all looking up at the same stars, and we all felt the same need to answer back. Our modern world hums to a rhythm set in stone ages ago. The 24-hour day we meticulously schedule is a gift from ancient Egyptian star watchers, who divided the night into segments based on the passage of 36 different star groups. Their star clocks evolved into the system of hours we use today, a direct link from the banks of the Nile to the clock on your wall. Even our calendar, the framework for our entire year, is a direct descendant of Roman reforms that sought to harmonize the stubborn mismatch between lunar months and the solar year. Every time you glance at a date, you are reading a refined version of a solution first attempted by sky observers 2,000 years past. The fundamental directions we rely on, the north on a compass, point to a celestial truth. The compass needle aligns with Earth's magnetic field, which ultimately leads us back to the rotational axis, the same invisible line around which the entire sky appears to turn. This is the very same celestial pole that the pyramid builders used as their fixed reference for aligning their colossal structures. This ancient reliance on the sky finds its most advanced expression in the global positioning system. Every turn-by-turn direction your phone gives you depends on a network of satellites broadcasting exquisitely precise timing signals. This synchronization is the modern equivalent of a priest at Chaco Canyon using a sun dagger to mark the solstice, a need to anchor human activity to a reliable external rhythm. We have simply traded standing stones for satellites, yet the underlying principle remains unchanged. So, are we in the 21st century still living by rules written in the sky by our ancestors? The evidence is all around us in every measured second and every mapped coordinate. This is not a forgotten art. It is the living, breathing foundation of our global society, a testament to the enduring power of that first human who looked up and decided to build an answer. Their legacy is written not in ink, but in the silent, enduring language of geometry and light. We have walked in the footsteps of those who first mapped the heavens with nothing more than monoliths and shadows, uncovering a lost science of breathtaking sophistication. From the solstice alignments of Stonehenge to the equinox serpents of Chichen Itza, a single, profound truth emerges. These ancient architects were not primitive mystics. They were the brilliant scientists and engineers of their age, master observers who patiently decoded the universe using only stone and sunlight. They grasped the slow dance of celestial cycles, from the sun's reliable annual journey to the moon's complex 18-year rhythm, and they engineered their world to harmonize with it. They built calendars that could predict eclipses and designed tombs that captured a single beam of light on the shortest day of the year. transforming cosmic events into powerful, repeatable spectacles. These structures are far more than ruins. They are eternal testimony to a fundamental human drive, our timeless curiosity, and our deep-seated need to find order and meaning in the vast cosmos. This quest connected the celestial to the earthly, turning the sky into a sacred text read by priests and farmers alike. So the next time you glance at a calendar or feel the warmth of the sun on your face, pause for a moment. Remember the millennia of patient observation, the generations of knowledge keepers, and the sheer intellectual triumph that made such simple, modern acts possible. This exploration is merely a starting point for your own curiosity. We would love to hear which of these ancient wonders captured your imagination the most. Was it the private solstice miracle at Newgrange, or the public descent of the serpent at Chichen Itza? Share your thoughts in the comments below, and if you are eager for more journeys into the mysteries of our past, we invite you to subscribe for our next adventure.